Good morning, ladies and gentlemen. It's a big honor for me to be invited here to this event and to present HUV LED UV printing. The question is it reality or is it a myth? So, once upon a time, there have been people reporting about two new technologies bringing fantastic results, curing 400% of ink coverage. So this was really sounding very nice, but to be honest, in the beginning, I was doubting. Maybe I'm too much a technical guy, and I'm basing my decisions and my opinions too much on facts. So let's join me and deep dive a little bit more into the basics and the facts and the figures about HUV LED UV printing. So the UV curing printing technologies, they're competing with the traditional oil-based oxidative drying inks. And as you know, in the oxidative drying inks, the ink consists of resins which are drying by oxidation, and they are diluted in different oils, vegetable oils, mineral oils. And these oils, after applying on the paper, are penetrating into the substrate, and the ink is starting to dry. The whole process takes a very long time, and as we heard before, this is one of the limitations also for the offset printing, because to get a real dry print, a hard dry print, it takes several hours, sometimes up to 2 days even, if we print on plastics, for example. The UV curing technology is completely different and is much faster. The UV inks, they're consisting also of resins, which are called oligomers, and thinners or oils, which are called, in this case, monomers. And additionally, we are using photoinitiators to start the whole drying process. So once we apply the ink on the substrate and we pass the ink under the UV lamp, the polymerization process is getting started and the ink is dried immediately. So this drying process is happening within milliseconds. So it's a huge difference and in the speed, but also a big difference because we are independent of the substrate. We don't need a substrate absorbency, so we can print on non-absorbent materials, we can print on different quality papers, and the ink is getting out of the press, cured and dry. So that's one of the big benefits. As we know, offset printing sometimes is having its limitations and difficulties. And especially the difficulties, we can see them in the finishing. And very often, when conventional printers are doing the finishing, it's already too late. So they get the rubbing, they get the marking issues, they get the blocking set off, all this kind of issues can happen, but you cannot see it when you run the job. That's one of the big limitations we can see, especially in Europe, where a lot of people, a lot of customers are printing predominantly on matte-coated papers or uncoated papers. So UV printing, we know, is bringing some benefits in the terms of set off, blocking, as the ink is fully cured and is sorting the machine as a dry film. But what are now the differences between the classical UV printing, the HUV and LED printing? Looking at the lamp spectrums of a classical UV lamp, the mercury, you can see here the blue bars, is having a wide width of more than 200 nanometers. So it's going from 200 nanometers up to 400 nanometers. And LED, in comparison to this spectrum, you can see is very narrow. We have a monopeak with a width of around about 20 nanometers only. So how can this work now? Seeing the differences in the spectrum. The simple explanation is the LED and HUV lamps are much more powerful in the UVA region So this means that the radiation coming from the lamp is penetrating much deeper into the ink films and therefore making sure that the ink film can be properly cured. But one thing you need to know about UV printing in general, independent of the system itself, I mean, depending on the different lamp types which are available, the ink formulation needs to be adjusted. And as I said, the photoinitiators are one of the main parts who are responsible for starting the reaction. So if the photoinitiator is not activated by the UV radiation coming from the lamp, the reaction will not take place or will be not as efficient as it could be. And this exactly is also the case in the LED printing. You can see there are a lot of photoinitiators available which are working in the classical UV, but which are not working in the LED case. So to get the optimum result with LED printing, it is very important that the ink formulation and also the varnish, the OPV formulation, is well adapted. So we know some people who invested into LED technology, and just to keep the costs down, they are trying to use standard UV inks. It can work to a certain degree, but of course it will not be the optimum. Coming back to the stories I mentioned in the beginning, so all the pros of the HUV LED printing, I'm just going to repeat it, and this is not the story I heard, this is really the experience I collected myself and the experience I gained together with the cooperations we had with our partners and with our customers. So these are day-to-day results they are achieving, and it's not a snapshot, it's not a marketing gag. So quality-wise, what we have seen, if we compare conventional printing, offset printing, but also classical UV printing, we have seen that we can achieve, in comparison to conventional especially, a much higher contrast of the image. The reason for this is the UV ink, the HUV LED ink, is not penetrating into the substrate, and therefore we get a very nice holdout, which is resulting in this sharp and very powerful image. The second effect we are getting there is that the whole image, the color is looking much brighter than in the case of the conventional oil-based ink. And as the curing is complete, also the mechanical resistances are much higher compared to, I would say, a classical UV ink, and also compared to the conventional ink. So this helps us also in the case of the perfector machines, for example, to reduce the coating or to eliminate the coating, which of course at the end of the day is also having a cost impact. Differently to the classical UV inks, the HUV and LED inks are showing also a higher gloss level. This is very important because if you compete with conventional, the gloss level was one of the big differences we have seen in the past. And there the gap is getting smaller thanks to this new technology. And also, like with the classical UV inks or UV systems, we can print easy on non-absorbent substrates, so also films or metallized substrates are easy to handle and are easy to process. And the cure speed also is given there. And talking about commercial printing, but also packaging, it is possible to diversify. So using UV curing technology, you can combine not just the printing of the inks, but also you can apply different effects, like for example, strip-off varnishes, matte gloss effects, etc. And this can be done all in a line. Coming to productivity and to cost in use. So we have seen that some of our customers, they have replaced their conventional sheet fed presses by the HUV or LED presses. So we know customers who had 2 presses running conventional in 3 shifts, and they have replaced 2 machines with 1 perfector machine, and they have been able to increase the productivity. This was also thanks to the production speed. The ink consumption was going down because of the good holdout of the ink. In average, the ink consumption can go down 10–20% depending on the substrate they're printing. And also the energy consumption is gonna be reduced. So for example, if you take a 50 by 70 centimeter format sheet fed press running conventional with a coater unit, the energy consumption is around about at 88 kilowatt per hour for the dryer only, for the IR dryer. And in the case of LED or in the case of HUV, the energy consumption for the dryer unit itself, for the lamp unit itself, will be at 25 kilowatt. So you can see there's a huge reduction in energy. And the additional effects, we heard it in the presentation before, digital is crucial. That's correct, and it's very crucial also for offset printing. What we've seen with all the customers who implemented HUV or LED printing, they had to adapt the finishing because the speed was increasing that much and the pass through the finishing was improving that much without having, with eliminating all the issues I described in the beginning. Now the whole process is speeded up as well. This is a big plus. And also, due to the faster finishing, they can reduce their space they need for stocking the pallets to wait for the finishing. And also, it's more environmental friendly because due to the lower energy consumption, also the CO2 balance is getting much better. And the big benefit in comparison to the conventional offset printing is that those presses don't require the usage of spray powder anymore. And the HUV lamp and the LED lamp are not forming the known ozone, which is the case in the classical UV printing. So you don't need the exhaust system. It's a much nicer environment for the printers as well to run such presses. How is the development looking like of these technologies? I put it together some figures for the European market, and I divided them into the HUV installations and the LED installations. And as you can see, HUV was starting 2010 at Drupa, and in the last 7 years, we have now gone to a number of round about 270 installations in total in Europe for HUV. And in the case of LED, it was starting later in 2014, and up to today, we are estimating around about 200 installations running already LED UV in offset in Europe. In the case of LED, the majority of the installations are retrofittings. But what we see now, more and more new presses and new installations are coming with complete LED equipment on. And not just the small ones, also the big ones. So the perfector presses, the internet printers, all those customers and applications are stepping now really into LED. And you can see the trend going up faster than it was for the HUV. But both technologies are still continue to grow. If you look on the worldwide picture, you can see, I mean, the HUV and LED printing technology was established in Japan after the Fukushima. There was a need to go for lower energy consumption, and this was the pusher, I would say, for these 2 technologies. So therefore, Japan at the moment still is the biggest market. The second biggest region you can see is Europe, then a smaller portion in North America. And what is picking up quite a massively, I would say, is the Asian region. Still, the figures are on a low level, but the number of installation and the interest we can see is clearly showing that also HOV and LED is starting to pick up in these regions. Just one word about India. So according our informations we have from the market, there are around about 20 installations running LED. Also, a lot of them are retrofittings. And I'm sure that also in the commercial area, there will be more installations coming in the future. So the installations you have seen here, they have been made mainly in the commercial printing. So the packaging printing is not really starting with it. Or there are limited customers who are really going for these investments. So the customers who had invested in these technologies are mainly the oil-based commercial conventional printers. And the applications they are doing, you can see here some examples. So these are flyers, brochures, inserts, displays, books, etc. So these are the standard commercial print stuffs. As I told you, packaging is also starting right now, not to this high level what we have seen in the commercial area, but already we have the first installations starting in LED with, for example, IML printing. So the printing on OPP material. They are using the LED technology because the lamp system is creating less heat, so they have less register problems. And there we have, not just only in Europe, but also in North America, we are getting the first installation at customers using LED technology. These installations there, they are also running LED low migration inks already. So also, it's feasible, it's possible to formulate low migration inks using HOV and LED technology. But so far, the biggest problem was if you do the cost comparison between the classical UV and the HOV or LED low migration printing, still the cost for the consumables is higher than the costs they're actually having. But we are pretty convinced that also the trend will continue in packaging. And especially when it comes to new investments, we can see definitely the trend that our customers are thinking about these technologies, and most of them are starting to invest into these technologies. So, coming back to the question in the beginning, is HOV LED printing a myth or is it reality? So, based on the figures you have seen and the experiences and the feedback we got from our customers, we can clearly say it's not a myth anymore, it's really reality. And it's a pity that Dr. Shahani is not present anymore, so we can say offset is changing as well. So we know it's time, and offset is doing it as well. Thank you very much.